Good morning, dear students. Myself, Dr. Priya, working as Associate Professor in Chemistry, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. So, in today's session, we are going to learn about polymeric materials. That is its introduction part. As I told you, nomenclature of polymers will be discussed in this today's session, like its functionality, definition of polymer, degree of polymerization reaction, and functionality, and then tacticity of polymers with a few examples. Let us start with introduction to polymers. So, how can we define polymers? So, we can define polymers as macromolecules, or we can say huge molecules. Macro means very huge in size. That means these kind of molecules will have very heavy molecular weight. So, these were formed or produced by linking together of large number of small molecules which are known as monomers. Small molecules which are known as monomers by using covalent bonds. These small molecules are what we call it as monomers, and the process of combining these monomers to form a macromolecule or huge molecule is called polymerization reaction. So, in this we have learned three different types of terms. One is polymer, the other one is monomer, and the third definition is polymerization reaction. So, polymers are macromolecules. So, actually the root word of this polymer is from Greek language. Poly means many, mer means units or parts. So, many parts or many units they combine to form a huge or macromolecule which is called polymer. So, that's why polymers are considered to be macromolecules or huge molecules which were produced by linking together of large number of small molecules, and these small molecules are known as monomers. So, because of linking together of two or more same or different monomers, a huge or macromolecule it is produced which is called polymer. And that process of combining these monomers is what we call it as polymerization reaction. Say for example, I consider the example of ethene or ethylene. This compound name it is ethene or ethylene. So, it is an example for alkene, and as eth means presence of two carbon atoms, presence of two carbon atoms, eth means, so that means ene is nothing but alkene. A presence of double bond will be there between two carbon atoms. I have considered the example of ethene, or we will call it as ethylene, in which eth means presence of two carbons will be there, and ene means alkene, that is presence of double bond between the two carbon atoms. And what is the valency of carbon? It is 4. So, here with one carbon atom 2 it is fulfilled. So, remaining 2 valency will be fulfilled by hydrogen atoms. So, as a whole if you notice, this will have 4 hydrogen atoms. That is simply saying CH2 double bond CH2. This is nothing but ethylene or ethene molecule. So, this is considered in n number of times. How many moles I have considered? N number of moles I have considered. N means infinity we can consider. So many number of moles of ethylene or ethene we have considered in this case. So, if these were subjected to polymerization reaction, that means these are nothing but monomers. Monomer name is ethene or ethylene. So, if these were subjected to polymerization reaction, that means simply combining these monomers, it is able to form its corresponding polymer, that is polyethylene or polyethylene. So, if you notice the mechanism part during the polymerization reaction, what will happen? So, this is what we call it as unsaturation. Unsaturation means either double or triple bonds will be present between two different carbon atoms. If any unsaturation if you notice, that means presence of pi and sigma bonds will be there. So, pi bonds will need very less amount of energy when compared to sigma bond in breaking process. So, this pi bond will be easily involving in breaking process. That means breaking of one pi bond and formation of two sigma bonds on either side of carbons will take place parallelly. So, that's why a polymerization reaction will take place, and a polyethylene or a polyethylene will be the product that is produced. So, if you notice the structure, this is nothing but the repeating unit which is going to repeat in the polymer backbone. So, as I told you, poly means many and mer means units or parts. That's why it is named like polymer, which is nothing but Greek language. Its root word is from Greek language, and the repeating unit that is present in the polymer is nothing but mer, which is coming from monomer molecule. The number of repeating units present in the polymer chain is what we call it as degree of polymerization. So, same example I am going to consider again. So in which how many number of moles I have considered? N number of moles. This N is what we call it as degree of polymerization. Degree of polymerization reaction. So the how many number of moles of monomers are participating in the polymerization reaction is nothing but degree of polymerization reaction. That means number of repeating units we have to check. How many number are repeating in the monomer? That number will reveal the degree of polymerization. So, and coming to the next property, this is nothing but property of monomer, that is called functionality. How it is defined means the number of reactive sites or bonding sites that were present on the monomer molecule. It is what we call it as its functionality. Functionality will exist for monomer, and how many number of reactive sites or bonding sites that were present in the monomer molecule we have to check. So basing on that one, its functionality will be revealed. Say for example, if you notice the previous reaction, that is ethene or ethylene. So in which we have considered n number of moles, right? So in this, how many reactive sites are there, or we can say how many bonding sites are present. That means how many reactive sites are participating in the polymerization to take place. So this is the place, or we can say carbons which are participating in the polymerization reaction. Say for example 1 and 2. So this 1 and 2 carbon atoms are participating in the polymerization reaction. So the number of bonding sites or reactive sites present in the this polythene formation, it is 2. That's why it is named to be bifunctional in nature. Bifunctional in nature. So that is what here it is discussed. A monomer which is having 2 reactive sites is named to be bifunctional in nature, and with 3 reactive sites is named to be trifunctional in nature, and more than 3 if it is having, then we will call it as polyfunctional in nature. So at least 2 reactive sites should be present for any monomer to involve in polymerization reaction. For any substance or for any chemical to call it as monomer and to undergo polymerization reaction, at least it should have 2 reactive sites or 2 bonding sites. That means it should be at least bifunctional in nature. Then only it can be named as monomer and it is able to undergo polymerization reaction. So this is the must and should condition. Minimum requirement is 2. That means it should be bifunctional in nature. Example here I mentioned, one olefin like ethylene or ethene is considered to be bifunctional in nature because it is having 2 reactive sites or bonding sites. When the double bond it is involving in breaking process, 2 sigma bonds on either side of carbons will be produced during the polymerization reaction. So this is example 1, that is polythene or polyethene. N moles we have taken, and this is carbon 1 and this is carbon 2, which were represented like asterisk, that is star mark. So how many bonding sites are there in this compound? 2 bonding sites are there. So this is bifunctional in nature, right? So this is what I have mentioned here, bifunctional monomer. So during that polymer linking, so if you notice, linking will take place between C2 and C1. First unit C2 is going to link with this is 1 and this is 2, right? So it is going to link with the first carbon of second unit. Similarly, first carbon of second unit 1, 2, 1, 2. So likewise, this is example for bifunctional monomer. So if it is for the case of trifunctional monomer, this will be the linking. So what is functionality? Functionality is defined as the number of reactive sites or bonding sites that were present on monomer molecule will reveal the functionality of that monomer molecule. So let us go with the next topic, that is types of polymerization reaction. So in general, we have different types, 4 different types of polymerization reactions. One is addition polymerization, second one is condensation polymerization, and third one is copolymerization, and fourth one is coordination polymerization. So let us start with the first one, that is addition polymerization. So before going to that one, let us have an idea about polymerization reaction first. So the process in which 2 or more same or different monomers involve in combination repeatedly, then they will result in the formation of a macro or a Hughes molecule, that is called polymer, and that process is what we call it as polymerization reaction. How many types are there in general? 4 different types of polymerization reactions are there. So first one, it is addition polymerization, second one is condensation, third one is copolymerization, and fourth one is coordination polymerization. Let us start with the first one, addition polymerization. This is also known as chain growth polymerization. So, how it can be defined means, it is the reaction that yields a product which is an exact multiple of the original monomer molecule. That addition polymerization reaction, it is normally instigated with the help of a catalyst or by applying some amount of heat or pressure or light. So, this is purely meant for breaking down of double bonds that were present between the monomer molecules. As a result, new bond formation will take place. So, that means this addition polymerization will be defined as the polymerization reaction in which two or more same monomers will combine to form a huge molecule. That means simple addition will take place. So, that repeating unit will go on adding continuously to the monomer units. So, that type of polymerization reaction is what we call it as addition polymerization. As we notice that chain is going to develop by the addition of repeating units number of times, then it is named as chain growth polymerization reaction. So, same example we are going to consider, that is polymerization reaction of ethylene, that is ethene or ethylene. So, n moles of ethene, if it is subjected to polymerization reaction in the presence of a catalyst like hydrogen peroxide, H2O2, or benzoyl peroxide will also play the role of a catalyst, and then 1000 to 1500 atmospheres pressure and then 250 degrees temperature. So, by maintaining these kind of experimental conditions, if this ethene or ethylene, it is subjected to polymerization reaction, and it is able to form its corresponding polythene as polymer. So, let us see a few examples. So, for this one, if I replace this hydrogen with the chlorine, then its example will become as that is vinyl chloride, C double bond C, H, and Cl I am going to replace. This is nothing but vinyl chloride, and moles I am going to consider vinyl chloride, and moles we are going to consider. If it is subjected to polymerization reaction, then what will happen? Just like in the case of ethylene, wherever we have this hydrogen, we have to replace with chlorine atom. So, this is the pi bond, it is involving in breaking process. As a result, a new sigma bond formation on either side of carbon atoms will take place. So this is chlorine. So, this is what we call it as PVC, polyvinyl chloride. So, this PVC is having lot of applications in construction side. It is used for carrying various kinds of water, various kinds of chemicals like water, oil, crude oil, natural gas, chemicals likewise. So, PVC is another example. Similarly, if you notice, if this hydrogen, it is replaced with the C6H5, that is phenyl ring. This is what we call as styrene. That means C double bond C. Here it is like H, and then here we have to consider the phenyl ring. So, this is what we call it as structure of styrene. Name of this compound, it is styrene. If it is subjected to addition polymerization in the presence of catalyst, that is H2O2, hydrogen peroxide, and then 1000 to 1500 atmospheres and some 250 degrees centigrade temperature, then what will happen? This pi bond involves in breaking. As a result, we can notice new sigma bond formation on either side of two carbon atoms, right? So, here this is what we call it as polystyrene. What is the name of this compound? Polystyrene. So, this is example 3 for addition polymerization. So, if you notice one small logic behind this type of polymerization, that means what is the monomer name here? Styrene. In the case of polymer, it is converting like polystyrene. Monomer name will be included in the polymer name. So, that's why it is example for addition polymerization. This is one more identification for addition polymerization. So, let us go with the second type, that is condensation polymerization, or we will call it as step growth polymerization. So, in this type of polymerization reaction, two or more same or different monomers involved in polymerization reaction, and the formation of polymer molecule will take place due to the elimination of small molecules like HCl, ammonia, water, and then methanol. So likewise, small molecules will be eliminated during the polymerization reaction. Say for example, here I am going to consider the example of hexamethylene diamine. So hexamethylene diamine. So what do you mean by methylene? Methylene group is nothing but CH2. So how many times it is going to repeat? Hexa means 6. So CH2 it is to be taken 6 times. So and it is connected to amino group. How many amino groups are there? 2 different amino groups. Hexamethylene diamine. Short form it is HMDA. So it is on either side it is connected to amino group, that means NH2. So this is what we call it as hexamethylene diamine. So this we are going to consider n number of times. N number of times of hexamethylene diamine we are going to consider. This is the structure of hexamethylene diamine. What is the name of another monomer? Adipic acid. This is the structure of adipic acid. This also we are going to consider n number of times. Adipic acid. Adipic acid. So adipic acid is the best example for divoic acids. That is, two carboxylic groups will be there. That is what we call it as divoic acid. First one it is oxalic acid, and then malic acid will have one CH2 group, that is one methylene group, and then succinic acid, glutamic acid, and finally to adipic acid. So this adipic acid will have 4 methylene groups. So if these two were subjected to condensation polymerization reaction, that is going to take place. So in which what will happen? So if you notice the reaction, so this is the first monomer and this is the second monomer. Both we have considered n moles. So from this amino group, hydrogen will be eliminated, and from this carboxylic group, OH will be eliminated. So likewise, as a whole, if you notice, water molecule is going to eliminate. So from this also, OH is going to eliminate, and from this also, H is going to eliminate. So here, minus 2NH2O, water molecule will be eliminated. So that if you notice the structure of this polythene, what will happen? See, as I told you, water molecule is going to eliminate. So that means if it is for the case of first nitrogen, what is the valency of nitrogen? It is 3. I removed one hydrogen here, so it will get a bond here, right? So and then it is having 6 hexamethylene substitution, that is CH2 6 times. So it is linked to next amino group NH2. So this nitrogen here I removed the hydrogen atom. So here for carbon it is OH minus, it is removed in the form of H2O. So we can expect a new bond formation between nitrogen and carbon. So nitrogen is going to connect with the C double bond with the new sigma bond formation. So and then this C double bond carbonyl compound is having methylene 4 times repetition, and then C double bond O. So if you notice the functional group, that is CONH. Here I will write C double bond O NH. That is what we call it as amide functional group, CONH, or simply we will write like CONH. That is amide functional group. So that's why it is also known as polyamide. This nylon 66, it is also known as polyamide. And one more thing is there. If you notice this hexamethylene diamine, how many number of carbons are there? Here it is CH2, it is repeating 6 times. That means number of carbons, it is 6 in this case. And if you notice the second monomer, that is adipic acid, here CH2, that is methylene group, it is repeating 4 times. That means 4 carbons plus 5, 6. So 2 carboxylic acids, they are having 2 carbon atoms. So 4 plus 6 altogether it is coming to 6. So first monomer is having 6 carbons and second monomer is also having 6 carbons. That's why it is also named as nylon 66. Nylon 66, what it will reveal? Nylon compound, it is obtained from 6 and 6 carbon atoms from each monomer. Sometimes we can notice nylon 610, nylon 611 like that. So it is able to reveal the composition of carbon atoms that were present in the monomer molecule. So that's why name of the compound it is given, right? So this is amide functional group, and that's why it is also an example for polyamide. So in today's class, so far what we have discussed is introduction. I started unit 3, that is polymeric materials, and then introduction to polymers, definition of polymer, what is monomer, and then what do you mean by degree of polymerization reaction, that is represented like n, small n, degree of polymerization reaction, and then functionality, what do you mean by functionality with few examples, and then types of polymerization reactions, how many types of polymerization reactions are there. So far these things we have discussed. How many types are there? 4 different types of polymerization reactions are there: addition, condensation, copolymerization, and coordination polymerization. In that I just gave the introduction for addition and condensation polymerization reactions with 1 or 2 examples for each type. So in the coming session, that is in the next session, we are going to study about the mechanism part of addition polymerization reaction, and later other examples for condensation polymerization reaction. So that's all for today's class. Have a nice time. Thank you so much.